A season is a division of the year, marked by changes in weather, ecology, and hours of daylight. Seasons result from the yearly orbit of the Earth around the Sun and the tilt of the Earth's rotational axis relative to the plane of the orbit. In temperate and polar regions, the seasons are marked by changes in the intensity of sunlight that reaches the Earth's surface, variations of which may cause animals to go into hibernation or to migrate, and plants to be dormant. During May, June, and July, the northern hemisphere is exposed to more direct sunlight because the hemisphere faces the sun. The same is true of the southern hemisphere in November, December, and January. It is the tilt of the Earth that causes the sun to be higher in the sky during the summer months, which increases the solar flux. However, due to seasonal lag, June, July, and August are the hottest months in the northern hemisphere, and December, January, and February are the hottest months in the southern hemisphere. In temperate and subpolar regions, 4 calendar-based seasons are generally recognized: spring, summer, autumn and winter. Ecologists often use a 6-season model for temperate climate regions that includes pre-spring and late summer as distinct seasons, along with the traditional 4. Hot regions have 2 or 3 seasons: the rainy season and the dry season, and, in some tropical areas, a cool or mild season. In some parts of the world, special seasons are loosely defined based on important events such as a hurricane season, tornado season, or a wildfire season. Causes and effects. Axis tilt. The seasons result from the Earth's axis of rotation being tilted with respect to its orbital plane by an angle of approximately 23.5 degrees. Regardless of the time of year, the northern and southern hemispheres always experience opposite seasons. This is because during summer or winter, one part of the planet is more directly exposed to the rays of the sun than the other, and this exposure alternates as the Earth revolves in its orbit. For approximately half of the year, the northern hemisphere tips towards the sun, with the maximum amount occurring on about June 21. For the other half of the year, the same happens, but in the southern hemisphere instead of the northern, with the maximum around December 21. The 2 instants when the sun is directly overhead at the equator are the equinoxes. Also at that moment, both the North Pole and the South Pole of the Earth are just on the terminator, and hence day and night are equally divided between the northern and southern hemispheres. At the March equinox, the northern hemisphere will be experiencing spring as the hours of daylight increase, and the southern hemisphere is experiencing autumn as daylight hours shorten. The effect of axial tilt is observable as the change in day length and altitude of the sun at noon during a year. The low angle of sun during the winter months means that incoming rays of solar radiation is spread over a larger area of the Earth's surface, so the light received is more indirect and of lower intensity. Lower intensity light is less able to heat the ground. Between this effect and the shorter daylight hours, the axial tilt of the Earth accounts for most of the seasonal variation in climate in both hemispheres. Elliptical Earth orbit, compared to axial tilt, other factors contribute little to seasonal temperature changes. The seasons are not the result of the variation in Earth's distance to the Sun because of its elliptical orbit. In fact, Earth reaches perihelion in January, and it reaches aphelion in July, so the slight contribution of orbital eccentricity opposes the temperature trends of the seasons in the northern hemisphere. In general, the effect of orbital eccentricity on Earth's seasons is a 7% variation in sunlight received. Orbital eccentricity can influence temperatures, but on Earth, this effect is small and is more than counteracted by other factors. Research shows that the Earth as a whole is actually slightly warmer when farther from the Sun. This is because the northern hemisphere has more land than the southern, and land warms more readily than sea. Any noticeable intensification of the southern hemisphere's winters and summers due to Earth's elliptical orbit is mitigated by the abundance of water in the southern hemisphere. Maritime and hemispheric, seasonal weather fluctuations also depend on factors such as proximity to oceans or other large bodies of water, currents in those oceans, El Niño plus or minus OENSO and other oceanic cycles, and prevailing winds. In the temperate and polar regions, seasons are marked by changes in the amount of sunlight, which in turn often causes cycles of dormancy in plants and hibernation in animals. These effects vary with latitude and with proximity to bodies of water. For example, the South Pole is in the middle of the continent of Antarctica and therefore a considerable distance from the moderating influence of the southern oceans. The North Pole is in the Arctic Ocean, and thus its temperature extremes are buffered by the water. The result is that the South Pole is consistently colder during the southern winter than the North Pole during the northern winter. The cycle of seasons in the polar and temperate zones of one hemisphere is opposite to that in the other. When it is summer in the northern hemisphere, it is winter in the southern hemisphere, and vice versa. Tropics. In tropical and subtropical regions there is little annual fluctuation of sunlight. However, there are seasonal shifts of a rainy global-scale low-pressure belt called the Intertropical Convergence zone. As a result, the amount of precipitation tends to vary more dramatically than the average temperature. When the convergence zone is north of the equator, the tropical areas of the northern hemisphere experience their wet season while the tropics south of the equator have their dry season. This pattern reverses when the convergence zone migrates to a position south of the equator. A study of temperature records over the past 300 years shows that the climatic seasons, and thus the seasonal year, are governed by the anomalistic year rather than the tropical year. Mid-latitude thermal lag. In meteorological terms, the summer solstice and winter solstice do not fall in the middles of summer and winter. The heights of these seasons occur up to 7 weeks later because of seasonal lag. Seasons, though, are not always defined in meteorological terms. In astronomical reckoning by hours of daylight alone, the solstices and equinoxes are in the middle of the respective seasons. Because of seasonal lag due to thermal absorption and release by the oceans, regions with a continental climate which predominate in the northern hemisphere often consider these 4 dates to be the start of the seasons as in the diagram, with the cross-quarter days considered seasonal midpoints. The length of these seasons is not uniform because of the elliptical orbit of the Earth and its different speeds along that orbit. 4-season calendar reckoning. Calendar-based reckoning defines the seasons in relative rather than absolute terms. Accordingly, if floral activity is regularly observed during the coolest quarter of the year in a particular area, it is still considered winter despite the traditional association of flowers with spring and summer. Additionally, the seasons are considered to change on the same dates everywhere that uses a particular calendar method regardless of variations in climate from one area to another. Most calendar-based methods use a 4-season model to identify the warmest and coolest or coldest seasons which are separated by 2 intermediate seasons. Modern mid-latitude meteorological. Meteorological seasons are reckoned by temperature, with summer being the hottest quarter of the year and winter the coldest quarter of the year. In 1780 the Societas Meteorologica Palatina, an early international organization for meteorology, defined seasons as groupings of 3 whole months as identified by the Gregorian calendar. Ever since, professional meteorologists all over the world have used this definition. Therefore, for the Northern Hemisphere, spring begins on March 1, summer on June 1, autumn on September 1, and winter on December 1. For the Southern Hemisphere, spring begins on September 1, summer on December 1, autumn on March 1, and winter on June 1. In Sweden and Finland, meteorologists use a non-calendar-based definition for the seasons based on the temperature. Spring begins when the daily average temperature permanently rises above 0 degrees Celsius. Summer begins when the temperature permanently rises above +10 degrees Celsius. Summer ends when the temperature permanently falls below +10 degrees Celsius, and winter begins when the temperature permanently falls below 0 degrees Celsius. Permanently here means that the daily average temperature has remained above or below the limit for 7 consecutive days. This implies 2 things. First, the seasons do not begin at fixed dates but must be determined by observation and are known only after the fact. And second, a new season begins at different dates in different parts of the country. Mid-latitude astronomical. Astronomical timing as the basis for designating the temperate seasons dates back at least to the Julian calendar used by the ancient Romans. It continues to be used on many modern Gregorian calendars worldwide, although some countries like Australia, New Zealand, and Russia prefer to use meteorological reckoning. The precise timing of the seasons is determined by the exact times of transit of the Sun over the tropics of Cancer and Capricorn for the solstices and the times of the Sun's transit over the equator for the equinoxes, or a traditional date close to these times. The following diagram shows the relation between the line of solstice and the line of apsides of Earth's elliptical orbit. The orbital ellipse goes through each of the 6 Earth images, which is sequentially the perihelion on anywhere from January 2 to January 5, the point of March equinox on 20th or 21st March, the point of June solstice on 20th or 21st June, the aphelion on anywhere from July 4 to July 7, the September equinox on 22nd or 23rd September, and the December solstice on 21 or December 22nd. The astronomical seasons are not of equal length, because of the elliptical nature of the orbit of the Earth, as discovered by Johannes Kepler. From the March equinox it takes 92.75 days until the June solstice, then 93.65 days until the September equinox, 89.85 days until the December solstice and finally 88.99 days until the March equinox. Variation due to calendar misalignment. The time of the equinoxes and solstices are not fixed with respect to the modern Gregorian calendar, but fall about 6 hours later every year, amounting to 1 full day in 4 years. They are reset by the occurrence of a leap year. The Gregorian calendar is designed to follow the astronomical seasons as accurately as is practical, though it does not follow them perfectly. Also see, Gregorian calendar seasonal error. Currently, the most common equinox and solstice dates are March 20, June 21, September 22 and December 21. The 4-year average will slowly shift to earlier times in coming years. This shift is a full day in about 70 years. This also means that in many years of the 20th century, the dates of March 21, June 22, September 23 and December 22 were much more common, so older books teach these dates. Note that all the times are given in UTC. People living further to the east, whose local times are in advance, will see the astronomical seasons apparently start later. For example, in Tonga, an equinox occurred on September 24, 1999, a date which will not crop up again until 2103. On the other hand, people living far to the west whose clocks run behind UTC may experience an equinox as early as March 19. Change over time. Over thousands of years, the Earth's axial tilt and orbital eccentricity vary. Thus, 10,000 years from now Earth's northern winter will occur at aphelion and northern summer at perihelion. The severity of seasonal change the average temperature difference between summer and winter in location will also change over time because the Earth's axial tilt fluctuates between 22.1 and 24.5 degrees. Smaller irregularities in the times are caused by perturbations of the Moon and the other planets. Traditional solar, Europe and East Asia, solar timing is based on insolation in which the solstices and equinoxes are seen as the midpoints of the seasons. It was the method for reckoning seasons in medieval Europe, especially by the Celts, and is still ceremonially observed in some East Asian countries. Summer is defined as the quarter of the year with the greatest insolation and winter as the quarter with the least. The solar seasons change at the cross-quarter days, which are about 3–4 weeks earlier than the meteorological seasons and 6–7 weeks earlier than the customary astronomical seasons. Thus, the day of greatest insolation is designated midsummer as noted in William Shakespeare's play A Midsummer Night's Dream, which is set on the summer solstice. On the Celtic calendar, the traditional first day of winter is November 1. Spring starts February 1. Summer begins May 1. The first day of autumn is August 1. The Celtic dates corresponded to 4 pagan agricultural festivals. The traditional calendar seasons in China and some other East Asian countries are variations of the solar method. They are traditionally based on 24 periods known as solar terms, and begin just after the cross-quarter days between the solstices and equinoxes. The traditional first day of the Chinese winter is November 10. Spring begins February 7. Summer starts on May 10. The first day of autumn is on August 10. Calendar deviations from four-season reckoning. Although most calendar-based reckonings use a four-season model, there are some calendars, especially in South Asia, that use a six-season method where the number of seasons between summer and winter can number from 1 to 3. As with other calendars, the dates are fixed at even intervals of months and are the same everywhere regardless of local variations in climate. Traditional South Asian, in the Hindu calendar of tropical and subtropical India, there are 6 seasons or ritu that are calendar-based in the sense of having fixed dates: Vasanta, Grishma, Varsha, Sharad, Hemanta, and Shishira. The 6 seasons are ascribed to 2 months each of the 12 months in the Hindu calendar. The rough correspondences are: Bengali calendar is similar but differs in start and end time. It has the following seasons or ritu. Tamils follow a similar pattern of 6 seasons: polar day and night. Any point north of the Arctic Circle or south of the Antarctic Circle will have one period in the summer when the sun does not set, and one period in the winter when the sun does not rise. At progressively higher latitudes, the maximum periods of midnight sun and polar night are progressively longer. For example, at the Military and Weather Station Alert located at 82°30 €2 05 €3 N and 62°20 €2 20 €3 W, on the northern tip of Ellesmere Island, Canada, the sun begins to peak above the horizon for minutes per day at the end of February, and each day it climbs higher and stays up longer. By March 21, the sun is up for over 12 hours. On April 6 the sun rises at 0522 UTC and remains above the horizon until it sets below the horizon again on September 6 at 0335 UTC. By October 13 the sun is above the horizon for only 1 hour 30 minutes, and on October 14 it does not rise above the horizon at all and remains below the horizon until it rises again on February 27. First light comes in late January because the sky has twilight, being aglow on the horizon, for increasing hours each day, for more than a month before the sun first appears with its disk above the horizon. From mid-November to mid-January, there is no twilight. In the week surrounding June 21, in the northern polar region, the sun is at its highest elevation, appearing to circle the sky there without going below the horizon. Eventually, it does go below the horizon, for progressively longer periods each day until around the middle of October, when it disappears for the last time until the following February. For a few more weeks, day is marked by decreasing periods of twilight. Eventually, from mid-November to mid-January, there is no twilight and it is continuously dark. In mid-January the first faint wash of twilight briefly touches the horizon, and then twilight increases in duration with increasing brightness each day until sunrise at end of February, then on April 6 the sun remains above the horizon until mid-October. Non-calendar-based reckoning. Ecologically speaking, a season is a period of the year in which only certain types of floral and animal events happen. So, if we can observe a change in daily floral animal events, the season is changing. In this sense, ecological seasons are defined in absolute terms, unlike calendar-based methods in which the seasons are relative. If specific conditions associated with a particular ecological season don't normally occur in a particular region, then that area cannot be said to experience that season on a regular basis. Modern mid-latitude ecological, 6 seasons can be distinguished which do not have fixed calendar-based dates like the meteorological and astronomical seasons. Mild temperate regions tend to experience the beginning of the hibernal season up to a month later than cool temperate areas, while the pre-vernal and vernal seasons begin up to a month earlier. For example, pre-vernal crocus blooms typically appear as early as February in mild coastal areas of British Columbia, the British Isles, and Western and Southern Europe. The actual dates for each season vary by climate region and can shift from one year to the next. Average dates listed here are for mild and cool temperate climate zones in the Northern Hemisphere. Pre-vernal begins February or late January, March. Deciduous tree buds begin to swell. Migrating birds fly from winter to summer habitats. Vernal begins March, April. Tree buds burst into leaves. Birds establish territories and begin mating and nesting. Estival, begins June in most temperate climates. Trees in full leaf. Birds hatch and raise offspring. Serotinal, generally begins mid to late August. Deciduous leaves begin to change color. Young birds reach maturity and join other adult birds preparing for fall migration. Autumnal, generally begins mid to late September. Tree leaves in full color then turn brown and fall to the ground. Birds migrate back to wintering areas. Hibernal, begins December, November. Deciduous trees are bare and fallen leaves begin to decay. Migrating birds settled in winter habitats. Modern tropical ecological, in the tropics, where seasonal dates also vary, it is more common to speak of the rainy season versus the dry season. For example, in Nicaragua the dry season is called summer and the rainy season is called winter, even though it is located in the northern hemisphere. In some tropical areas a three-way division into hot, rainy, and cool season is used. There is no noticeable change in the amount of sunlight at different times of the year. However, many regions are subject to monsoon rain and wind cycles. Floral and animal activity variation near the equator depends more on wet-dry cycles than seasonal temperature variations, with different species flowering at specific times before, during, or after the monsoon season. Thus, the tropics are characterized by numerous mini-seasons within the larger seasonal blocks of time. Indigenous ecological. Indigenous people in polar, temperate and tropical climates of northern Eurasia, the Americas, Africa, Oceania, and Australia have traditionally defined the seasons ecologically by observing the activity of the plants, animals and weather around them. Each separate tribal group traditionally observes different seasons determined according to local criteria that can vary from the hibernation of polar bears on the Arctic tundras to the growing seasons of plants in the tropical rainforests. In Australia, some tribes have up to 8 seasons in a year, as do the Sami people in Scandinavia. Many indigenous people who no longer live directly off the land in traditional often nomadic styles, now observe modern methods of seasonal reckoning according to what is customary in their particular country or region. Official designations, by definition, the meteorological seasons start about 3 weeks ahead of their counterparts sometimes called official in the Northern Hemisphere. The earlier starting meteorological seasons are customarily or officially observed in the largely maritime mid-latitude climates of the Southern Hemisphere. This is because of the milder winter temperature regime over and near water that leads to an earlier arrival of spring weather. With the earlier spring date established, the other seasons are timed accordingly at 3-month intervals. Because of the cooler temperatures during the run-up to spring observed in the predominantly continental mid-latitude climates north of the equator, the common convention for some countries of the Northern Hemisphere is to observe the later arriving season starting around the 21st of a month. These different observances are largely informal and have not generally been legally proclaimed by governments north or south of the equator. Instead, any official status of the meteorological seasons comes from the World Meteorological Organization only claims to make official designations for the meteorological profession. In these contexts, official, a largely media-driven term when used for the start of any calendar-based season, has to be taken as meaning customary or symbolic rather than legal. See also, equinox, growing season, Indian summer, Persephone, Greek mythological figure associated with the rebirth of vegetation in the spring, solstice, sun path, Vertumnus, Roman god of the seasons, references. Mares, Mihaela, St. Lucian School, Bacău, Romania, Seasonal Variations of the Bird Species, Ref Ecological Seasons PPA 195 Euro 196 Inkling PPA 207 Euro 209 Inc. External links. When do the seasons begin? Southern Hemisphere calendar, solstice does not signal seasons start, while the Earth has seasons article on H2G2. Aboriginal seasons of Kakad, indigenous seasons, Mount Sterling seasons, the lost seasons, Melbourne 6 seasons, the lengths of the seasons, Earth distance versus tilt, tutorial on Earth-Sun relations and seasons, satellite photo demonstrating seasons changes in 2004 on NASA website, video. How seasons change looks from the space.